we have and again we should probably is this the syllabus? Yeah, this is actually we need to go through that objective here. Let's just check the syllabus for a little confirmation here. And we're gonna zoom in. All right, we have some more details to do with these acids, but then what we are looking at here is this objective. It's actually objective 9. That I guess you should be able to see it. All right, no, this topic is it's gonna be like a practical topic in the sense that we should be doing some labs to show this. No, I'm trying to work on a virtual lab to bring this, but I haven't been able to find any virtual lab. So, but here are the objectives, guys. It says here, conduct investigations leading to the classification of substances as conductors or non-conductors. All right, fine. So that's basic stuff. We're not really spend time on that one. But distinguish between metallic and electrolytic conduction. All right, there you go. So metallic, it has to do with metallic bonding. Electrolytic has to do with ions, and so we're actually doing that indirectly. But look at what this is where crucial thing is. And 9.3, 9.4, guys. 9.3 saying that classify electrolytes as strong or weak based on their conductivity. Use of acids, salts, and alkalis as electrolytes. So we are actually going to confirm here with you guys that all salts, all acids, and all bases are electrolytes. Salts would be example sodium chloride, which we looked at last. One example here, but any salt, it's actually any salt. So it could be anything that in with a chloride or anything in with a sulfate or nitrate, anything like that can conduct electricity. All right, but acids now would be another topic by itself. Define electrolysis. Think we have done this before in some questions, and we have the cathode and the anode, anion and cation. This is what we need to know for CXC. And then what we have here, identify ions present in electrolytes. So that's something we're doing last class. Okay, doing 9.5 there. All right, 9.6 says predict the electrode to which an ion will drift. That's also what we're doing. So these are objectives that we are actually trying to let you guys learn. But when guys students are silent now, so problem, you don't know whether they're learning or not. So where here is 9.7 says predict the chemical reactions by using or making use of the electrochemical series. All right, so all right, that brings us to our revision, guys. So what we actually doing are whoa, this is a very big topic, a very big topic. Look at that, actually 10 objectives if you check it out. 9.10 here, and the possibility is a 9.11. So electrolysis is huge, guys, very huge, huge. So the best way to do this is to, well, it would have been to do a lab, and that's gonna be challenging due to the fact that it's a more face-to-face lab. And the only way I could get close to showing you is if I show you a video of it. So that might be something on the table later on. All right, but right now it's just 9.7, 9.6, 9.5 identify presenting ions presenting electrolytes. So if we say that electrolytes now, so electrolytes, and I don't know if I give you a definition for electrolyte, but let's bring up a definition for electrolyte, right? Because it's close to the word electrolysis, but it's different. All right, different meaning. So let's go ahead and see what comes up for electrolyte. All right. Or anybody has any idea of what an electrolyte is? Um, they have 12 persons in the class. Perhaps at least one could
Yes, sir.
say,
No, I
yeah,
have
you know what it
idea.
is. I have an idea. All right, hold on. Stick up in there. Um, Anybody else have an idea? There's you guys can't hide behind Benito tonight. So nobody knows what an electrolyte is.
No, sir.
No, okay, Kimberly, I understand your situation, but yeah, you don't know. All right, let's give it to you then, because it was said. I know I gave it to you.
Sir, now you my part. I will make say.
Oh, well, all right. Well, did you get it in class?
Yes, sir.
Oh, all right. Let me hear what I have to say then.
When ionic compound melts are dissolved in water, the solution that is formed that electrolyte.
Okay. All right. Yeah, I'll accept that. Yeah, whenever an ionic compound is molten or in aqueous state and can allow current to pass through it, then that's an electrolyte. So to simplify that, or to can cement that definition, we can have a look at this. All right, everybody seeing this?
Yes, sir.
So that's the definition here. We're gonna use this definition, and there it is. Substances that can conduct electricity when they are in molten state or aqueous solution, and undergo chemical changes. All right, because they generally consist of ions in solution. Electrolytes are also known as ionic solutes. Well, definitely that's extra information. But certainly the first part there is just a substance that can conduct electricity when they are in a molten or aqueous state. That's it. All right. All right. So there's actually more. Let me just scrap this. I don't think you don't need this part. I'll just give you the definition part. What would be nice though is for you to let's see who is here. Oh, Deborah. Oh, Deborah. So some making a grand entrance here at this hour. All right. All right. Remember that electrolytes again from this information that you're seeing here. Electrolytes don't conduct an electric current when they are in a solid state. They have to be molten or aqueous. Okay, so all right, let's just so some fix up that here. And actually they actually have a reason why. Let me just crop out here. The reason for this happening here. And the reason there, electrolytes there. Is that water? We understand what water is polar. So remember water is polar. So water is polar because we say that it have because we say the water behave like this. It have one H and so it have two H and one O, and then one part negative. All right, and the oxygen in group 6 bonding with hydrogen, sharing the electrons there, and sharing in that one there. So okay, fine. So we have these electrons. These are gonna be negative. This will be positive. What happened? Water is polar. That's what polar mean. So when dissolving water, the molecule separate into plus and minus ions there. And that's crucial. So when those ions now are present in water, what happens now if you put some NaCl in there? NaCl will come in like this. And actually it's gonna the two ions really don't touch each other. They're just strongly attracted to each other. So I don't fully touch, but then sodium is positive and then chlorine and the chloride ion is negative. All right, what's gonna happen here? We're gonna have if salt is placed in water, we're just going to have a situation where salt moves, salt separates the into sodium. Sodium will go there and chlorine will go here. Positive ions attract to negative, guys. Opposites attract. So and then what they have happening there? This separate. All right, they separate. So this is what electrolysis does, in a sense. All right. So that does that. All right. So that's the story, guys. So that's an electrolyte substance that can conduct electricity when they are in molten, or molten means that you just melt it. Like probably use a torch and make it melt by itself. Or it can be aqueous where you just say, well, dissolve it in water. All right, which is you just say that it's well, it's like a easier way to melt something, because you technically you're melting salt when you put in water, and it's changing into liquid. But it's just the only difference though is that when you put it in water, you're going to have more ions in the water. So in this case, put the salt in water, you end up with you're going to end up with H plus, you're going to end up with Na plus, you're going to end up with OH minus, and then you're going to end up with Cl minus. So these ions will be in water if rather, yeah, these ions will be in the in the aqueous one. So, and then this is a case where if you're gonna do it this way, like you can't really, there are certain things you won't get when you pass current through it. Remember, you don't just want to pass current through a substance just for people to see or to say you do a experiment. No, it's not just for school. It's really for business actually. People do electrolysis for business, because if I'm in the business of making chlorine, I'm going to need a whole heap of salt. All right. So I'm making chlorine to sell, commercially to people that going to make bleach, to people who going, well, I guess they're going to purify the water or want to throw some in the tank that they have at home. I am supplying those people. So electrolysis is a business, guys. It's not a topic. It's a business. Everybody get that?
Yes, sir.
Yes,
All right.
sir.
All right. So, and it's a very big business too. So you have to think about, because you're going to set up current, in fact, you're going to need a lot of current to run this thing. You're going to need stuff, and then you're going to need raw materials, which the companies that do electrolysis, let's see. Well, these a lot of these companies are actually in the US. They can't be out here because electricity too expensive out here. So by the time unless you're going to use solar, and even then the solar, you're going to need like a whole heap of panels to get that current. So long story short, they do these things in the US for a living, for business. So you're making chlorine, you need your current, you need your salt, and of course you need big containers to store everything. And then you pass your current through your salt solution, you collect your chlorine in a container that can store chlorine. That's another thing too. If you're making chlorine at a place, it's a health hazard, so you have to protect persons from it as well. So chlorine is dangerous like that. But a simple way you can actually get chlorine though. Well, and we could actually, well, And if face to face allow it, you know, you could actually just add some you could add some sulfuric acid to some salt. You get some salt that you have at home. Put tip a little sulfuric acid on it, and you're going to actually get a little fizzing thing, and then you're going to get some chlorine gas coming out. So that's a simple way to make chlorine. But otherwise, to make a lot of it, you're going to need current to pass through some salt solution. So you can actually do it at home. But then I won't tell you to try it at home because if something goes wrong, you could get shocked. You know, salt is a good conductor of electricity when combined with water. So careful. All right, so that's our electrolyte story, guys. So that's what an electrolyte is. Anybody have any questions?
No, sir.
All right. Okay. That's something here now. All right. So let's see, I wanna show you something there. And then definitely want to see the sodium chloride situation there. And again, guys, this is don't try this at home. And I want you to watch this. I'm actually telling you from experience, so that thing I tried it. Yeah, I actually did try it some time ago. But all right, and here goes. Let me share the screen. All right. What is in the screen?
Yes, sir. Yes, sir.
All right, so I'm on screen 3, and here we go.
On a smaller scale in the laboratory.
All right.
What happens in electrolysis before going any further? The electrolysis of brine is an industrial process which is carried out on a large scale, but we can look at the process on a smaller scale in the laboratory. Brine is a saturated solution of sodium chloride. We don't want the electrodes to become part of this reaction, and so we use carbon electrodes.
All right, stick up in there, guys. All right, so what you're learning here, seeing that you can actually control the electrodes that you use, right? The electrodes that you put into the experiment will determine what happens, in the separation that's supposed to take place here. So carbon electrodes are said to be inert electrodes, guys. They don't take part in chemical reactions. All right, so let's continue. All right.
From the sodium chloride, we have positive sodium ions, Na+, and negative chloride ions, Cl-. And from the water, we have positive hydrogen ions, H+, and negative hydroxide ions, OH-. When the current flows, you will begin to see tiny bubbles of gas forming at each electrode. Both hydrogen and chlorine gas are formed. But can you work out which electrode produces which gas?
All right, that's a good question. Which electrode will produce which gas? Anybody have any ideas here? Because we're seeing the plus and we're seeing the minus. Where would the chlorine go and where would the hydrogen go?
Sir,
Yes.
so the chlorine will go on minus.
Chlorine will go to the minus. All right. Which means automatically that the hydrogen will go to the plus then.
Yes, sir. Yes, sir.
All right, good. Let's see. Let's watch the video and see if that's true. All right.
Pause the video and see if you can work it out.
Oh, well, look at that. Didn't know that they take to pause the video. But then you say that. All right. Hope everybody is listening and understand what's happening here. Guys, Casey, it was you, right?
Yes,
actually I was actually saying, so Casey is saying that chlorine would go towards the negative electrode. Is it? Or I said positive. Which one?
I said negative, sir.
Chlorine will go to the negative electrode. All right. Okay, let's confirm that. Let's confirm that.
The chlorine is formed at the anode.
Well, therefore, it's actually there. So
Positive electrode.
it's actually at the positive. The way you have to understand now is that opposites attract. So if you know the chlorine is
Oh, oh, yeah.
yeah, opposite attract. So let's clear that up
Yes,
now,
sir.
guys.
Yes, sir. Come here, say.
Oh,
I would have
you're,
the positive side of dog, sir. No, no, yeah.
you see what's happening here now. All right. All right. So then that's it. That's it, guys. I hope everybody is learning from this. All right. The chlorine will go to the anode because chlorine is from the chloride anion. Anions go to the anode. That's how you reason it out. But you hear that?
Yes, sir.
Yes, sir. Yes, sir.
All right. So there you go. All right. Interesting. Oh, I think somebody.
And hydrogen is formed at the cathode. That's the negative electrode.
All right. So see there. Okay. The hydrogen there is going to go to the negative because it is positive. Hydrogen is a cation. Cation goes to the cathode. All right.
Did you get it right?
All right.
Let's look at what's going on at each electrode. The anode is positive and attracts the negative chloride and hydroxide ions. The chloride ions give up their electrons to the anode and are oxidized to chlorine molecules.
All right. So then basically now them introducing this term to you guys, oxidation. Now I should point out to you.
The loss of electrons.
Well, there you go. Oxidation is the loss of electrons. And
Sir, they already tell me, sir.
I told you.
No, I'm saying that they already told us. It says the chlorine, the negative give up their electrons.
Well, yeah, that's what's happened. So, all right. So remember, guys, that the chlorine atom would have gained an electron to form the chloride ion, but in the ion solution now, it will be attracted to the positive electrode. Now, what the positive electrode is doing is actually pulling electrons, the electrons that the chlorine atom had gotten to form the ion in the first place. When it does that now, the chlorine would no longer have that electron or electrons in this case because it's two chlorines would have gotten it. So
Ions.
so what will happen here is that the chlorine now would give up the electron that it had and return to what it was before, which is a yellow-green gas. All right, so let's see what happens.
Oxidize to make a diatomic chlorine molecule, and 2 free electrons are produced.
All right, so that's the idea here, guys. And so what we're also learning about the anode, not only that it is positively charged, but oxidation takes place there. And the definition for oxidation is that oxidation is a loss of electrons. All right. Now, I wrote this equation last class, but I wrote it in the other way. You notice that it's gonna be 2 chlorine going to form the chloride. Trying to see. Okay, and that's why they put it plus E minus there. The 2 E minus guy mean 2 electrons, and as the narrator was saying, they are free electrons. So yeah, the current basically pull them away from it. All right, but let's continue. Any questions about this, guys?
No, sir.
No, sir.
Okay, let's go ahead. All right.
The electrons are given up to the anode, and the chlorine gas bubbles up to the surface of the cell. If you collected the gas from the anode in a test tube, then you would be able to see the pale green colour of the chlorine gas. It will turn damp blue litmus paper red, showing that it is acidic.
All right, stick up in there, guys. No, with that, no. That's important information. Again, they could ask it how you test for chlorine gas. Very common question in CXC past papers. Looking through a few of them. All right, chlorine is an acidic gas, and then we test acids using litmus paper. But chlorine will not only change the color of blue litmus to red, but it will want to bleach it. Chlorine is a bleaching agent as well. So let's continue.
And then it bleaches it.
Yeah, okay.
Well, what about the cathode? It is negatively charged and attracts the positive sodium and the hydrogen ions. The hydrogen ions each gain an electron from the electrode to form hydrogen atoms. Here's the equation. Two hydrogen atoms then bond to form a diatomic hydrogen molecule, and that's the hydrogen gas given off. The gas here is colourless and can be collected in a test tube. The test to prove that it is hydrogen is done with a burning wooden splint, and you'll hear a familiar pop as the hydrogen burns. The ions left in the solution are the positive sodium ions and the negative hydroxide ions, which combine to form sodium hydroxide. Overall, the electrolysis of brine has produced hydrogen, chlorine, and sodium hydroxide, and so we can write a summary equation. Concentrated sodium chloride solution plus water, when electrolyzed, gives sodium hydroxide solution, hydrogen gas, and chlorine gas. These products are very useful, and the electrolysis of brine is done on a much larger industrial scale. Chlorine is used to kill bacteria, and it is soluble in water. If you've ever visited a public swimming pool, then you'll be familiar with the smell of chlorinated water, and it's also used to sterilise water in the mains water supply. What's more, chlorine is one of the main ingredients of bleach, which is used in a lot of cleaning products. But this is only scratching the tip of the iceberg, as chlorine is used to make dry cleaning ingredients, electrical insulators, building materials, refrigerator gases, weed killer, pesticides, antiseptic disinfectants. Some of the hydrogen and chlorine from the industrial process is combined to form hydrogen chloride gas. It's a rather unpleasant gas, but it dissolves in water to produce hydrochloric acid, which is a very useful acid. It too can be used for cleaning metal, but it is also used for producing chloride salts. Sodium hydroxide is another cleaning product, and the most common use for it in the home is for cleaning ovens and unblocking drains. That's a rather amazing collection of uses from our original brine.
Alright guys, so hope you you learn from that video, guys. You have any questions?
Hydrochloric acid in our stomach, sir.
Yes, it is. Wait, you don't have enough in yours?
No, just was asking. I always hear about it, sir.
Yes, you about it, but you never believe it.
And that's, sir.
Oh. Alright, well, you ever have indigestion before?
Repeat, sir.
You
No,
ever
sir.
have indigestion? Leandro, you never have that before?
No, sir.
You're 78, Leandro?
No.
Oh, I was checking. All right. No, I know, I ask 70 because 70 persons don't eat certain things in their diet, and therefore they're not likely to have indigestion. But certain times they eat food. Sometimes of the day you eat certain foods, your body don't like it, and it some persons can't eat certain foods because of the amount of acid them have in the stomach, and it has to do with the blood type that you have as well, and genetics as well. So persons who come from vegetarian families, for instance, if they have couple generations of kids who are vegetarians, then if you give them a piece of meat, then they will have a hard time dissolving it. So that's one of those things. All right, and in fact, yes.
Would colic fall under that?
Well, yeah, colic is interesting. Colic. Well, no, not really. I think colic is something different. It's colic refers to the pain where you cause from I think it's like a gas, almost like a gas pain. Or it's a pain associated inside the stomach. That's different. Indigestion is what happens when you have to take Andrews or something like that, or Dica. Anything that causes you to take one of those medications, Anybody have those things at home? Dica or Relcha?
Supposed to.
Yes. I don't think so. But sir, then I think you can use baking soda and warm water.
Okay, that's what you use?
Not me, but my mother.
Okay. See what I mean? Yeah, you can as I say, you have alternatives here. But yeah, so but you're seeing, guy, that why electrolysis is so important. That's I mean, that's the first thing you should appreciate, that electrolysis is useful, something that you can actually make a living from. Imagine if you were at a factory doing that electrolysis here. You'll always have a demand. People always want bleach and so on. Especially now since COVID time, these things have increased, and they're making a way for money now. So that's the story of electrolysis, right? So they have asked that in exam before. As a matter of fact, if we look at this question that I would have sent before, let's see if I can bring it up. Yeah, it was actually this paper that we did, and it started out here, and then it came all the way here, and it came into defining the term electrolysis, and we are learning about the video that we just saw here. In this question, sodium chloride is a typical sort of sodium metal concentrated sodium chloride solution brine. They can undergo electrolysis when it is used in an electrolytic cell. That was shown in the video, using inert electrodes. And we say that inert electrodes are those that don't react in the electrolysis. So in the video we saw where the carbon electrodes, did not affect what was formed, and that's it important. Right, that's important. It coming like, say you have a man, you have a man who's supposed to watch the place, but like you make him watch the place, but at the same time him help himself by stealing some of the stuff, type of thing. Like a security guard at some place, watch the place here, yes, but then them might try them thief out things when in the night and so, you probably know of those situations, so that's it. So, and that's like an electrode that is participating, in the reaction. But then when it's not participating, no, it's neutral. So it really doesn't care about what is happening inside the solution. No. And I said that when you're defining electrolysis, guys, remember to include the term current and of course electrolyte in molten or aqueous state. But certainly it's electric current separating. That's the key thing here, separating. All right, separating solution, and then solution current separating a solution. That's current separating a solution. Have to mention that, and also have to mention that electrolyte, the substance in there is an electrolyte. All right, so that's the definition for electrolysis, guys, and current passing through the electrolyte, separating it. They ask here, and this is where we didn't finish. It says here, write half equations including state symbols for the reaction that occurs at the anode and cathode during the electrolysis of there's a concentrated sodium chloride brine solution. So after watching the video now, guys, you'll be able to say, all right, sodium is positive, chloride ion is negative. So again, the anode. I always remember, guys, that with the battery or with any form of current, the anode is positively charged. Yeah, the cathode is negatively charged. All right, never forget that. All right, so, and then opposites attract. So therefore, if the cathode is negative, then cations are gonna go there. All right, so they name the electrodes based on what is going there. All right, so one them say if they ask for the equation of the anode, just tell yourself say anions are going there. Is that clear, everybody?
Yes, sir.
Then say anode. All right, so them ask the anode, you think about anions. If them say cathode, think about cations. That's it. So once you know say it's cations and anions I'm talking about, you write down the first one. You write down the answer there. All right, so them say half equation. So that equation that them show you in the video is what they're looking for. All right, it's actually gonna be well 6 marks. Them say here. Look at that, 6 marks. 6 marks right now, guys. So them if CXE giving us 6 marks in chemistry for anything, serious thing. So well, all right. So I know the chloride ions will go there. Did they say it's concentrated? Yeah, so concentrated means the same thing will happen. All right. Let's pause this a bit. I want you to go and look at something because last class I showed you this. Was it this? It was not this. It was this. All right. Everybody seeing this?
Yes, sir.
All right.
Yes, sir.
All right. And we'll talk about how we know what is going to come off at the electrode. Well, in this list, all right, if it's lower down and the rank, it means that it's going to come off first. All right, that's the idea here. So it's like, yeah. So like it's coming like your if you have a school and you wanna, I just say the school say you must release some students because you have too much. Right? Are you going to release your best students or your worst students?
Worse.
Worst, yeah. Just like that. Just like that. Or you have a bag full of some mango or apple or anything where you like, and then some of them kind of spoil or something now. And you're supposed to get rid of some. You're going to get rid of the spoiled ones. No, look at it this way. It's the same thing here with this list of cations and anions. The ones them were weak are at the lower or are lower in this list. And then those would be given off first in electrolysis. So we have hydrogen, and in the same sodium chloride electrolysis here, there was sodium as well. So both of these cations would be in the solution, but only one of them can be liberated. Turns out that it's hydrogen because hydrogen is lower. So in this rank, and then therefore, just basically have to come off. So less energy is required, guys. That's what they're saying here. This arrow is showing easy to discharge. So hydrogen is much easier to discharge than sodium. Any questions here?
No, sir.
All right. And then looking over here at the anions now, we're seeing where there's the hydroxide, and there was also the chloride as well. If we take there, chloride there, chloride and hydroxide were in the solution we were watching in the video, but it's the hydroxide that gets the preference. All right. Again, it's lower in the series, so and that's how it works. All right. So that's it. This reactivity series coming like the K system in India, where if you don't born in certain family, you can do certain career. All right. So all those people who follow in the Kardashians, just remember, say them reach where them reach because yeah, India is a shake up place, if I want to have a better word. But India is so shaked up. All right. So same caste system. So you're born in a rich family, you stay there. If you're born poor, you stay poor. So nobody can say, all right, I go to university and you come from a poor family. First of all, even if you do go, they won't treat you bad by the time, because in India, they know say when your skin dark, they know say you come from poor family. So it work over there. All right. The poor
Yes,
people.
sir. Resist sir. So you can't go to acting, sir. Sir, if dark skin, sir, you can't go to acting, sir. You have to be light skin, sir.
Wait, where you get that from?
Over India, sir.
No, you get that from over India? So you have been there?
No, sir, not that. I've said that if you're a dark skin, sir.
So you realize how lucky you are, Janari. If you were over in India, you'd be in problem.
Yes, sir. Then poor, sir.
Yeah. So look at that, guys. So you guys are lucky in Jamaica. Make the most of it because enough people in India. India, remember saying India have 1 billion people, guys, and lot of competition there. Bright Pitney over there can't can't pass certain level because them black, you know. No, let me say black mean dark skin. Them are Indian, but their skin dark. And the darkness of their skin they use for label it over India. All right. So when they come to Jamaica now, a lot of times, well, you see it's probably lighter skin Indians you probably see. So them one they have it a little easier. They can buy one plane ticket and so them will come. But you see the one them know where darker skin now come from the southern India, they so know. Yeah, them one they know in a little issue there. Them have to like do domestic work and something and them treat them like real animal. So and that's what we're living in. So I remember say when it comes to things like
False
chemistry,
gods, sir.
hmm?
Because of the false gods.
No, let's not go there. Just saying that to say that this reactivity series is a lot like that. Right? One them where lower down, you just get rid of them. If they want to kill, that's why India can test vaccine to, you know, guys. And I say India have a look on the poor dark skinned people them where them put in a lower rank and say, well, you know, can test the vaccine them on them. So them do it, you know. They can have about 250,000 of them. 250,000,000, I should say. They then can say, all right, they want to test it on 250,000,000 dark-skinned Indian people. And if
It's
none
like
of
when
them,
you do Africa, sir, like when India do syphilis, sir, in the 19th, sir, you can try to see out from Africa and trick them up and tell them, say, I want something that them give them one cure or something, and then tell them that they want virus, some implement in our system. And from there,
yeah,
say,
that's it.
HIV and syphilis spread, sir.
Yeah, Tuskegee experiment you're talking about. Yeah. Yeah.
White man did to, sir, they wicked, they say.
Yeah, well, I was just saying, guys, I was saying that to say that this is like it. But all right, guys, any questions?
No, sir.
No, sir.
No, sir.
All right, let's complete this that question then, because where's that question? It was over here. All right, good. We want to complete this question, guys. We want to show you how to write the ionic equation. Just understand that the anion chlorine is negatively charged, and that's actually redundancy anyway, but the anion, which is a negatively charged ion here, chlorine will not make it here, guys. It will be the other one. And so that's why I had stopped the question, because I was going to show you with chlorine, but I didn't want it to go home with that misconception here. So we would realize that it's actually going to be the OH that will come off, because in terms of the anions there, based on that list. In fact, I should probably copy it over here, so you always remember yourself of it. The CXC when test is hard, and then they test it hard, then you need to be able to rise to the occasion. So let's put that there. Let me see now, and copy paste side here. All right, there you go. All right, so we're agreeing that the anions here, this is what we're talking about, OH ion. So if the OH gonna come off, let's change this to black and fill out this. And it's gonna be, all right, OH minus there. All right, 6 marks for this, guys. You could, at the moment, you don't score any. And you say concentrated aqueous. Then you're going to have to say concentrated aqueous. And concentrated is actually, it's a same thing. It means the same thing as aqueous, but it means like you have more salt than water. That's when it's concentrated, but you still have water in there, so it's still going to be aqueous, which means that you're also going to have OH minus and H plus. And then what we're going to say now is that OH I will get the preference, H I will get the preference, sodium and chlorine have to go stay behind. But let's go back. Did the video say chlorine? Did the video say chlorine would be liberated? That's what it said. Did it say it was did they say it was concentrated? Yeah, they actually did, you know. I just also make sure that still. I wanted to confirm that still. All right. So let me give you a note here, guys. All right. Let me just and we're just in with this. That you can have dilute and you can have concentrated. We have to look out for the wording. And then if it's concentrated, then I'm going to have to go take off this. The reason for taking this off if it's concentrated is that concentrated means enough. You're going to have whole heap of sodium. And the rule says that if you have a whole heap of one ion, like if you have more chlorine than hydroxide ion in the solution, then the chloride, even though it is higher up in the series, the fact that it's more of it, then it's gonna liberate. So hence the concentrated scenario is a factor. Dilute now means more water, then therefore you'd have, a different thing here. But them say concentrated, guys, so bear that in mind. All right. Concentrated and dilute solutions are different in electrolysis. So if it's concentrated now and it's brine, then concentrated means you have no fight then. So we're going right back to chlorine. So this was actually correct. All right. So Cl minus, where them say no, 1 mark for saying that in the electrolysis, the current, the electrons will leave it. And so you're gonna write something like this. In fact, when them say oxidation is lost, so and this says put oxidation here. This is where you're going to get a mark now. Just take what I'm telling you in the video. Oxidation occurs at the anode. All right. Cathode, opposite of oxidation is reduction. All right. Next thing, oxidation is the loss of electrons. All right, loss of electrons. That's
by
the
an
definition.
element or something.
Yeah, by any substance. And then reduction now is what? Reduction is the opposite of loss, which is gain of electrons. That's it. Once you know this now, we can finish this. So oxidation means loss of electrons. So I'm going to put a minus sign here, and chlorine, because we know that it's only got 1 electron in the bonding process, then you're going to take away that 1 electron. Let's put the E there. And then it's going to form Cl2, what it was before, which is chlorine gas. Probably just, I don't want to, it's confused here. All right, so take away that electron, it's going to leave you with chlorine. However, chlorine exists as a gas now, which means that it is diatomic. So diatomic means 1 atom can't form the substance. You're going to need 2. And so we'll put the 2 there. However, if we have the 2 chlorine here, we had to have 2 here to start with. So we'll come into something called balancing the equation here. Chlorine is always Cl2, guys, in nature. 2 chlorine ions will therefore lose 2 electrons. Notice I said 2 chlorine ions, not chlorine atoms, but chlorine ions, right? Ions, chlorine there, taking 2 electrons from this. This will be a gas, and this is okay. So this is it. So you get 3 marks for that. So you're getting 3 marks for saying this part, and you get the other 3 marks for doing this. All right, which this part is easy now. If it's hydrogen, if this gain, so if this lasts, then this going gain. So you will have like H plus, and then of course there's add the electrons there, and then of course you're going to end up with hydrogen gas forming. And remember that hydrogen gas, any gas written in formula, in a reaction is diatomic. Yeah, and then we're going to put the gas there. If you have 2 hydrogen, we must have 2 here, so to begin with. So we have to balance it off here with 2, and there you go. That's the marks. That's the 6 marks. All right, so just have a couple of points to remember though, guys, that look out for the word dilute or concentrated. All right, dilute or concentrated. So we're going to talk more about this in future classes. So any questions here, guys?
No, sir.
No, sir.
All right, well, that's it. That's it. So yeah, as you can see from the syllabus, guys, there are 11 important things to learn about electrolysis. This is one of them, how to write equations. This is very major. And also it is tied in with oxidation and reduction. Know those definitions, guys. We'll talk more about this on Wednesday class again. Thursday? No, Wednesday. Yeah, we'll talk more about this on Wednesday, guys. All right.
Yes, sir.
One day, is there another class after this?
Maths.
Yes, sir. Bio.
Okay, bio maths. All right, guys. All right, so all right, thanks for coming out, guys, and Enjoy the rest of your evening. All right.
Same to you, sir. Yes, sir.
All right.
Same too.
All right.
Bye, sir.
Yeah, bye.